Hey guys, Myers Mathematics, and let's just jump right into it. Why are vertical and horizontal lines different? Why are they different from other lines? Right. So if you've come across these types of lines, you've probably noticed that teachers will tell you, right, that for and I'll use green and red to kind of contrast the two. For vertical lines, they'll tell you x equals a number, right? And then for horizontal lines, you've got y equals a number. And then, you're supposed to know, if it's vertical, it's x, if it's horizontal, it's y. And, the easy thing to do would be maybe to just be like, oh, well, I'll just remember that, um, x is the vertical one and y is the horizontal one, and I'll just remember it. Okay? And that's fine. If you wanna stop there and just remember which one is which, that works. But if you're wondering why, it's because of the line formula, okay? So if you've talked about lines at all and graphing lines, regular sloped lines, meaning, it's tilted, then you've come across this formula, right? This is called the slope-intercept form. Okay, slope-intercept form, excuse me. It's called slope-intercept form because it gives us exactly that. It gives us the slope, m equals slope, right? And the letter m, fun fact, the reason why it's for slope is believed to have been because it represents a mountain, montana in Espanol. And since it has to do with a mountain has a great slope, and so the two coincided. At least that's one theory. And then B for the y-intercept. And I don't have a fun backstory to that one, unfortunately, but it is what it is. It be what it be. So you have B equals the y-intercept, m equals slope. Okay, that's your line formula. And if you've graphed a line before, you know how it works. If not, let me just give you a quick example. All right, so let's say y equals 1/2 x plus 1. Okay, so then we go up one space and put a point, y. How did I know that from this graph? Well, I didn't start with the 1/2. I didn't go up one space because it's 1/2, because that's the slope. The 1/2 is the slope. The slope tells us how slopey the line is. It tells us how slanted the line is. It doesn't tell us where to start or where there's already a point on the graph. The y-intercept does that, which is the 1. The 1 is a y-intercept, so it's going to intercept the y line, meaning it's going to touch the y line. This is where it touches. So one way to remember intercept is B represents the point on y. B is the point on y. It's on the y-axis. Okay? And then m is slope, which is rise over run. Rise over run. Right? So I know it's going to be at 1 because the y-intercept tells me so. And then from there, I can go up one space and over two spaces. Because rise over run, my slope is 1/2. So I rise by the top number. This is my rise, 1. And then I run 2. 1, 2. All right. And I might make another video on just this, on how to graph these lines. But I'm kind of assuming in this video that you already kind of have a decent grasp on this, so I'm just going to do this one example. But that's how you would normally do it, right? Well, let's say that we wanted to try to figure out what this point is, right? This point, if you're good with points, right? And I have a video on how to graph a point, so go check that out if you're not sure how to graph points. But this point right here would be 0, meaning I don't go left or right at all from the origin. Right, there's the origin. And then I move up one space. Okay? Now, every point that's on the y-intercept, that's on the y-axis, okay? Every point is going to be something, comma something, more specifically 0, comma a number. Okay. Well, if every point that's on the y-axis is 0, comma something, that means that x is 0. That means that x is 0. So if every single time x is 0, if you have a point on there, what if I had 0 for x? What if I plug in 0 for x? If I plug in 0 for x, 1/2 of 0 plus 1. Well, 0 times anything is 0, right? So y equals 1. And then look at there. We have y equals 1, which is this point right here, right? Now, the easiest way to make this a whole line. So this y equals 1 is my result when I plug in 0 for x. But then you're thinking, or maybe you're not, and now you're thinking because I just said it, like, hey, doesn't this look like a horizontal line? Y equals 1? Well, it is. It is a horizontal line. So now let's look into what that graphs like. Here's how I know what that graphs like. Okay. So if on this graph here, right, I want the graph of y equals 1, then one way to do this is to simply say y equals 1 for every point. Okay? And this also then means that x can equal anything. There is no x, so x can equal anything you want it to. So we already know of a point where y is equal to 1. It's at 0, comma 1. At 0, comma 1, right here, y is 1. Well, where else is y 1? Well, it's y is equal to 1 right here. Right? This point would be 1, comma 1. The y value is still 1. And then I could keep going, right? You might be seeing a pattern here. 2, comma 1, right? That's a valid point in the graph of y equals 1 because y equals 1 for every point. In this point, 2, comma 1, y is equal to 1. X is equal to whatever I want it to be. So if x is equal to whatever I want it to be, then you get this continuation of points. And it goes like this. Okay? So that's the reason why, no pun intended, y equals 1 is a horizontal line and not a vertical line, right? Because you're thinking, well, wait, the y-axis goes up and down, right? So wouldn't that be a y? It's not. Because the y-axis is a name, and it's not actually the equation of the graph. Okay? So y equals 1 is a horizontal line because when you read a graph, when you read this graph, what you need to be thinking is that I need 2 points where y is equal to 1. Okay, so back up for a second. This is only one way to figure this out. The other way to figure this out is to use something called slope, right, which we talked about before. Y equals mx plus b, right? Y equals mx plus b is the equation for slope, for m, right? M is slope, gives us slope and intercept. Okay, so if I want a horizontal line, what do you think the slope would be? Well, it's 0. You're exactly right, unless you said something other than 0. So if I have a 0 slope, if y equals 0, right, for slope is 0, 0x plus b, then what happens? It doesn't matter what x is, because no matter what x is, y is equal to b. No matter what x is. I can plug in anything for x, right? X can be any number, right? And actually, let me erase that real quick. So x can be any number because any number times 0 equals 0, right? Any number multiplied by 0 equals 0. Because when you multiply by 0, you're basically saying, I want 0 of this number. So you just get 0. So then y equals b, meaning y equals a number, right? Because b is a y-intercept, so it just equals a number, aka a horizontal line. Boom, there we go. Now, the x is a little bit harder to do. So before I do the x, let me back up and give you an example of when x is equal to something. So let's say x equals 1, okay? Now, you already know, we already did y equals 1, so you're like, okay, horizontal line, so x equals 1, that's going to be a vertical line. It's the other one, so it's going to, look different. And yes, that is one way to do it. But if we have just started with this, with x equals 1, and I said graph this, right? You might not know what to do, right? You might feel like the little face that's created when you turn your head sideways, right? If you turn your head to the left, you can actually see that you have a meh face right here. Meh face, okay? And that's the face you're going to be making if you don't know how to do this. But if x equals 1, then all I need to do is say that means for every point, right, x comma y, for every point x comma y, x equals 1. So it's going to be 1 comma something. Okay, so now all we need to do is just come up with 2 points where I have 1 comma something. So here's 1, 1 comma 1, let's say. 1 comma 1. Okay, that works. It's 1 comma something. There is no y. It's just x equals 1. So it's just 1 comma something. Okay, now what about 1 comma 2? That works as well, right? Yeah, it does. And you could keep going, right? 1 comma 3, 1 comma 4, 1 comma 5. But 2 points is all you need to make a line, right? So there you go. There's your line. And it's vertical because x equals 1. And the other thing I didn't mention earlier is if x is equal to 1, x is stuck, which means y can freely go up and down infinitely, making a vertical line. Whereas when y is stuck at 1, right, it can't go up or down. It's stuck at 1. Y, it goes up and down, right? So if y is 1, it's stuck at 1, and x has free reign to go anywhere it wants. Okay? So now, last thing. Here's my analogy here of just plug in 0 for your slope. Now, this one's a little harder to do, so it's a little more confusing, so that's why I'm going to kind of save it for last here, because you don't need to know this to, figure out why it is what it is. But if you're looking for another reason why, here's something else you can do here. Y equals mx plus b, right? So if y equals mx plus b, and the slope is vertical, that means it's actually over 0. It's actually over 0. And this is where it gets tricky. Because if it's over 0, in theory here, what would happen is if I were to multiply by 0, it would make y 0. But it would also make b equal to 0 as well. So this is the reason why it's tricky to do this, to kind of show this algebraically, because when you divide by 0, you can't, just the universe breaks, right? It doesn't really do any good. But in order to make this work, all I'd really have to do is is well, let me just go ahead and do this. So this is not as algebraically sound as the first example, but if it's over 0 and I multiply by 0, right? I'm just going to multiply by 0. Multiply by 0. So that means that 0y equals x, right? The zeros would cancel, right? Again, this is not real algebra here. This is kind of made up algebra. Plus 0b, okay? Which means that x equals nothing, right? Because 0 times anything is 0. So x equals nothing, okay? Now, since I had to distribute the 0 into the b, it kind of made that go away. But really, b is only there to show me that I need to add something. I can add something in if I want. All right, so x equals 0 is a possible example of a slope that is undefined, but I can also make x equal to some other b value. It doesn't matter. You can make it equal to whatever you want. So it can still equal b, or negative b, or whatever. It can equal a number. Okay, so this one's not as easy to do algebraically because, again, you're dividing by 0 and it makes things go weird, but x can equal a number, so that means that I have a vertical line. When x equals a number, I have a vertical line because the y goes away. If y is 0, then I have an undefined slope. So actually, one way to do this might be to say instead 0y equals mx plus b. And then you could do it that way as well. You could divide both sides by 0 then. Right, so then you'd have m over 0 is your slope, right, plus b over 0. So it's, your b isn't defined too. So again, the algebra just gets kind of funky. But there you go. Right, so looking back at our examples here, if you have to run into horizontal and vertical lines, they're different because they're going not sloped. If it has some sort of slope, then there's going to be some sort of m value. And then algebraically speaking, right, meaning like numbers wise, we have a horizontal line when the slope is 0, right? So the slope goes away. But the slope kind of also goes away when you make the slope infinity or divided by 0, undefined. So there's two reasons why the slope might go away and I might just have an x or a y and not both. And that's when the slope is 0, giving me a horizontal line, and when the slope is something over 0, giving me an undefined or vertical line. Okay, so horizontal and vertical lines are different because they make the slope go away in one way or another. Okay, that m value, and they produce a horizontal or a vertical line, which, by the way, are always perpendicular. Horizontal and a vertical line will always meet at a 90-degree angle. Another fun fact. All right, this has been Mr. Myers Mathematics. Hey, if you haven't gotten my free guide, go check it out. It's on my website, myersmathematics.com. It's the 5 steps to never missing a math problem. Okay, it's not magic, it's science. You can go check it out. It's a free guide to just stick in your pocket and have on hand. I've boiled it down to 5 reasons, 5 things that I've noticed in 10 years of tutoring that everyone misses a math problem for one reason or another, and you can boil it down to 5 things. So I created a guide on those 5 things and how to alleviate or make sure that you don't miss a math problem according to the reasons why anybody ever can miss a math problem. So go check that out. It's a free PDF on my website, myersmathematics.com. Check it out.